Hello everyone, this is Ayushi. I look forward to discussing regression today. Introduction. Regression refers to a data mining technique that is used to predict the numeric values in a given data set. For example, regression might be used to predict the product or service cost or other variables. Regression refers to a type of supervised machine learning technique that is used to predict any continuous valued attribute. Regression helps any business organization to analyze the target variable and predictor variable relationships. It is a most significant tool to analyze the data that can be used for financial forecasting and time series modeling. Regression involves the technique of fitting a straight line or a curve on numerous data points. It happens in such a way that the distance between the data points and the curve comes out to be the lowest. Regression provides a good way to predict variables, but there are certain restrictions and assumptions like the independence of the variables, inherent normal distributions of the variables. Before applying regression analysis, the data needs to be studied carefully and perform certain preliminary tests to ensure the regression is applicable. There are non-parametric tests that are available in such cases. There are 5 types of regression in data mining: linear, logistic, lasso, ridge, and polynomial. Let's have a short introduction about each of them. The most popular types of regression are linear and logistic. Other than that, many other types of regression can be performed depending on their performance on an individual dataset. First is linear regression. In linear regression, the best fit line is achieved utilizing the least squared method, and it minimizes the total sum of the squares of the deviations from each data point to the line of regression. Here, the positive and negative deviations do not get cancelled as all the deviations are squared. Linear regression is a type of regression that forms a relationship between the target variable and one or more independent variables utilizing a straight line. The given equation represents the equation of linear regression: y equals to a plus b into x plus e, where a represents the intercept, b represents the slope of regression line, e represents the error, x and y represent the predict and target variables respectively. If x is made up of more than one variable, it is termed as multiple linear equations. Next is polynomial regression. If the power of the independent variable is more than 1 in the regression equation, it is termed a polynomial equation: y equals to a plus b into x squared. Applying linear regression techniques can lead to overfitting when you are tempted to minimize your errors by making the curve more complex. Therefore, always try to fit the curve by generalizing it to the issue. In the particular regression, the best fit line is not considered a straight line like a linear equation. However, it represents a curve fitted to all the data points. Logistic regression. When the dependent variable is binary in nature, that is 0 and 1, true or false, success or failure, the logistic regression techniques comes into existence. Here, the target value y ranges from 0 to 1, and it is primarily used for classification-based problems. Unlike linear regression, it does not need any independent and dependent variables to have a linear relationship. Ridge regression. Ridge regression refers to a process that is used to analyze various regression data that have an issue of multicollinearity. Multicollinearity is the existence of a linear correlation between two independent variables. Ridge regression exists when the least square estimates are the least biased with high variance, so they are quite different from the real value. However, by adding a degree of bias to the estimated regression value, the errors are reduced by applying ridge regression. Lasso regression. The term lasso stands for least absolute shrinkage and selection operator. Lasso regression is a linear type of regression that utilizes shrinkage. In lasso regression, all the data points are shrunk towards a central point, also known as the mean. This type of regression is well fitted for models that suffer from multicollinearity. The lasso process is most fitted for simple and sparse models with fewer parameters than other regression. Some applications of regression are sales forecasting, customer lifetime value prediction, churn prediction, employee performance prediction, financial performance analysis, risk analysis and fraud detection, maintenance prediction. Thank you.